Hello, grade threes. It's great to see you on this thrilling Thursday. It's the last day of our math lessons this week, and I am looking forward to going through our last lesson of Module 6 with you. So today we are doing Module 6, Lesson 9, and our learning objective says, I can analyze data to problem solve. So basically, we're going to be using data given through graphs and line plots, and we're going to be answering questions about it. All right, so before we get started, we need to make sure we have everything. We will need a math journal, our Learn book open to page 249, our Fluency book open to page 95, and for homework, our Succeed book open to pages 165, 166, 167, and 168. So if you need to go ahead, get those ready now. You can pause the video. When you're ready to start our lesson, just push the play button. Welcome back, grade threes. We are going to get started with our fluency practice. So the first thing we need to do today is we are going to be counting by sixes. So let's have our math hands ready. And we're going to get started, starting with 0, because 0 times 6 is 0. And I'm going to start with my left hand and work my way over. You're going to start with your right hand. Oh, wait, I'm going to start with my right hand. I'm sorry, and work my way to my left hand. You're starting with your left hand, just like when we write. All right, so let's get ready. 0, 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. And let's go back from 60 down to 0. 60, 54, 48, 42, 36, 30, 24, 18, 12, 6, 0. Let's do it one more time. Get ready, starting at 0, 0, 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Make sure you're counting along with me. And starting at 60, 60, 54, 48, 42, 36, 30, 24, 18, 12, 6, 0. Well done. They want to know what is 4 6s. For that, I'm going to draw my 0, and I'm going to go ahead and do my skip counting to 4. So let's go. 1, 2, 3, 4. And please say the skip counting with me as I draw. 0, 6, 12, 18, 24. 4 6s is not 26. It is 24. All right, let's go do another one. 48 divided by 6. I'm going to put my 0 in, and we're going to start at 48, and we're going to go backwards to see how many groups of 6s it takes to get to 0. So 1, 2, 3, 4, 5, 6, 7, 8 jumps. Say the skip counting with me, please. 48, 42, 36, 30, 24, 18, 12, 6, 0. 48 divided by 6 is 8 jumps. 8 groups of 6 is 48. Our next one, 3 8s. Let's get ready to count by 8s first. We're going to start with our 0, 0, 8, 0, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. And let's go back from 80 all the way to 0. 80, 72, 64, 56, 48, 40, 32, 24, 16, 8, and 0. All right, let's go up one more time, starting with our 0, 0, 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. And let's go back one more time. 80, 72, 64, 56, 48, 40, 32, 24, 16, 8, 0. All right, 3 8s. I'm going to start with my 0, and I'm going to do my jumps. So count with me. 8, 16, 24. I made my 3 jumps. 3 8s is 24. Now they want us to divide. I'm going to draw my 0. We're going to start at 56. Let's count backwards. 56, 48, 40, 32, 24, 16, 8, 0. And 56 is 7 jumps of 8. So 7 groups of 8 is 56. 56 divided by 8 is 7. All right, let's go to our next screen. They want us to count by 9s. So I've got my math hands ready. Please count with me. 0, 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. And let's count backwards. 90, 81, 72, 63, 54, 45, 36, 27, 18, 9, 0. 4 9s. I'm going to put my 0 and skip count with me, please. We're going to be making 4 jumps. So 0, 9, 18, 27, 36. 4 groups of 9 is 36. Our next one, they want us to divide starting at 54. Skip count backwards with me, please. 54, 45, 36, 27, 18, 9, 0. Altogether, I made 6 little jumps. So that means 54 divided by 9 is 6. Here we go. Let's do our 7s. We've already skip counted by 7s. So let's start off. And we want 6 times 7. So we're only going to skip count for 6 fingers worth of 7s. So let's get ready. 0, 7, 14, 21, 28, 35, 42. I've got my 6 fingers, 6 groups of 7. That means 6 times 7 is 42. Let's go ahead and do 5 times 7. 0, 7, 14, 21, 28, 35. 5 times 7 is 35. All right, well done, everybody. Let's move on to our next screen. They want us to count by 7s to get up to 8 groups of 7. So I'm going to stop when I have 8 fingers showing. Let's get ready. 0, 7, 14, 21, 28, 35, 42, 49, 56. 8 times 7 is 56. Let's skip count down to find that answer, starting at 70. That's 10 groups of 7. 70, 63, 56. 70, 63, 56. That's 8 groups of 7. 8 times 7 is 56. All right, let's skip count up by 7s to get to our answer of 7 times 7. So 7, 14, 21, 28, 35, 42, 49. I've got my 7 groups of 7. 7 times 7 is 49. Let's skip count down from 70. 70, 63, 56, 49. I've got 7 fingers left. 7 times 7 is 49. Doesn't matter whether you count up or down. All right, let's skip count up by 7s again. 9 times 7, we're going to end up with 9 groups of 7. I'm not going to count this time. I'm going to let you do the counting, but I will show you the fingers and the math hands. So, nine times 7 is 63. And let's count down from 10 groups of 7 down to 9 groups of 7. So we're going to start with our 10 groups of 7. Take away 1. 63. Well done. All right, so grade 3s, now is your time to get your fluency book out, open to page 95, and you can pause the video, ready to get started. Finish the whole page, and when you're done, just push play again, and you can come back to check our answers. See you soon, math superstars. All right, welcome back. Well done for finishing your 7 times table fluency page on page 95 of your fluency book. We're going to go through. Please make sure that you are saying the multiplication equation and the answers as I say them. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 7 times 10 is 70. 7 times 5 is 35. 7 times 6 is 42. 7 times 5 is 35. 7 times 7 is 49. 7 times 5 is 35. 7 times 8 is 56. 7 times 5 is 35. 7 times 9 is 63. 7 times 5 is 35. 7 times 10 is 70. 7 times 6 is 42. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 6 is 42. 7 times 8 is 56. 7 times 6 is 42. 7 times 9 is 63. 7 times 6 is 42. 7 times 7 is 49. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 7 is 49. 7 times 9 is 63. 7 times 7 is 49. 7 times 8 is 56. 7 times 6 is 42. 7 times 8 is 56. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 7 times 9 is 63. 7 times 6 is 42. 7 times 9 is 63. 7 times 7 is 49. 7 times 9 is 63. 7 times 8 is 56. 7 times 9 is 63. 7 times 8 is 56. 7 times 6 is 42. 7 times 9 is 63. 7 times 7 is 49. 7 times 9 is 63. 7 times 6 is 42. 7 times 8 is 56. 7 times 9 is 63. 7 times 7 is 49. 7 times 6 is 42. 7 times 8 is 56. All right, give yourself a total. See how you did. Well done, math superstars. What you can do next is you can open up to page 249 of your learn book. And I'll read our the question to you, and you can go ahead, you can pause the video while you solve the answer, and make sure you draw a picture or solve it and write your answer on the lines. It says, Marla creates a line plot with a ½ inch scale from 33 to 37 inches. How many tick marks should be on her line plot? All right, so we know that she's working with ½ inches. Remember, there are 2 ½ inches for every whole inch, because it's ½ inch, ½ inch, put together to make a whole inch. All right, so go ahead, figure that out. How many ½ inch lines would she need between 33 and 37 inches? Solve it, push pause, and when you're done, you can come on back ready to check your work. See you soon. All right, welcome back, grade 3. We are going to look at our application problem. So the first thing I did was I found out how many inches there would have been. So I said 37 inches minus 33 inches is 4 inches. And I know there are 2 ½ inch marks in each inch. So there would be 4 times 2 equals 8. So she would need 8 tick marks on her number line. I said Marla should have 8 tick marks on her line plot. Fantastic work. All right, grade 3s, you can turn to the next page, but we're not going to do our problem set yet. Page 251. You're going to be doing that after you finish watching the video. Right now, we're going to do our concept development. That means we need to make sure we have our math journals ready, our pencils ready, and our ears listening. I'll see you soon while you get ready, grade 3s. All right, grade threes, welcome back. Today, our learning objective says I will be able to analyze data to problem solve. So we're going to be looking at some graphs and we're going to be answering questions about them. So on the screen right now, we have our first graph and the title of our graph says money spent at the fair. We know at the bottom, it tells us some items or activities that our friends spent at the fair. On the left-hand side, we know this shows us how much money they spent on each activity. So we've got games, food, parking, and rides. Games, they spent $30, right? So I'm going to go ahead and I'm going to write a 30 above it so I know. Food, it's halfway. That bar for our bar graph is halfway between the 20 and the 30. Halfway between 20 and 30 is 25. So I'm going to put my 25 there. Parking is halfway between 0 and 10. And what number is halfway between 0 and 10? That's 5. So I'm going to put my 5 there. And rides is halfway between 30 and 40. So that is $35. All right. So now I know that I'm using this bar graph to answer a problem. And the problem says, how much more money was spent on rides than on parking? I'm going to look for some action words here. What action words can you find? I see how much more and than. And if it's how much more and than in a sentence, we know immediately we're doing subtraction. I also know I want to be looking for rides and parking. So how much did they spend on rides? They spent $35. How much did they spend on parking? They spent $5. In your math journal, see if you can come up with a subtraction sentence to solve this problem. If you need to pause the video, go ahead. Otherwise, when you're ready, just push play. All right, grade threes, welcome back. I know we solved that in our journals. I know $35 was spent on rides. Whoa, 35 on rides minus 5 on parking. So I'm going to go ahead. 5 minus 5 is 0. And 3 minus nothing is 3. So they spent $30 more on rides than on parking. Who got that right? If you got it right, give yourselves a pat on the back. Good work. If you didn't, go back, see what you were confused by. Our next one says the friends take a total of $120 to the fair. That's a lot of money. How much do they have left after the fair? So we want to find out how much they spent, and then we can subtract that from their $120 because they had 120 at the beginning and they spent all these amounts on the fair. So let's go ahead and we're going to make up a subtraction sentence. I said 120 minus, and now I'm going to come up with a total. I need to find out how much money they spent altogether. To do that, I'm going to look back. 30, 25, 5, and 35. So I know they spent 30 and 25. I'm going to add these together because I want to add those numbers up to find out how much they spent at the fair altogether and then take that away from my $120 total. So 30 plus 25 is 55. And then I'm going to add the next number, which was $5. So 55 plus 5. 5 plus 5 is 10, so I carry my 1. 1 plus 5 is 6, so 60. And we've got one more amount left. I'm going to start off with my 60 plus $35 that they spent on their rides 60 plus 35, 0 minus 5 I can't do, so I'm going to have to regroup. Make that into a 5, borrow 1. 10 minus 5 is 5. 5 minus 3 is, or 5, whoa, I'm sorry. I'm subtracting. I should be adding, shouldn't I? Silly me. So let me take that away. Here we are. Silly Mr. Dib. Oi. Honestly. All right. So 60 plus 35. I don't know why I subtracted. 0 plus 5 is 5. 6 plus 3 is 9. So they spent $95 at the fair. That's how much they spent at the fair. So I'm going to take that away from my 120. 120 minus 95. And I'm going to do this now underneath. I'm going to change my color. 120 minus 95. Make sure all my numbers are in the right columns. All right, and this is when it does get a little tricky. 0 minus 5 I can't do, so I cross out my 2, make it into a 1. 10 minus 5 is 5. 1 minus 9 I can't do, so I cross out my 1, make it into a 0, and I make that into 11. 11 minus 9 is 2. So they had $25 left over. There we go, 25. $25 left over. All right. If you got that right, give yourselves a pat on the back. If you didn't, go back and see where you might have gone a little wrong. All right, let's look at our next question. Our next question says, how much less did the friends spend on rides than on games and food combined? Combined means what? Well, combined means plus. So I need to add up how much they spent on games and how much they spent on food. And then less is subtraction. So I'm going to subtract that from the amount they spent on rides. So over here, games and food. Let's go back and see how much they spent on games. They spent $30 on games and $25 on food. So I'm going to add those up. 30 plus 25. Altogether, they spent $55 on games and food. And their rides cost them $35. So 55 minus the 35 for rides. And I'm going to go ahead and I'm just going to, I'm going to subtract. 5 minus 5 is 0. 5 minus 3 is 2. So they spent $20 more on games and food than on rides. Or you could say they spent $20 less on rides than on games and food combined. All right, there was another question here. It says, parking costs $1 for each hour. The group of friends arrived at the fair at 3 p.m. What time did they leave? Well, we know they spent $5 on their parking, so they were there for 5 hours. So 3 p.m. plus 5 more hours means they left at 8 p.m. 8 at night when they probably should have been in bed. 8 p.m. All right, well done, grade 3s. We're ready for our next chart, and here it is. This line plot shows the lengths of the crayfish in Mr. Nye's 3rd grade science class. All right, we know how to read a line plot. This should be pretty easy for us. The first question says, what is the total length of all the crayfish that are 3 inches long? So I only want to worry about these crayfish that are 3 inches long. So let's see, how many crayfish are there that are 3 inches long? I can count them up. 1, 2, 3, 4, 5, 6. So there are 6 crayfish that are 3 inches long, and they want to know how long all the crayfish would be all together. So I can easily turn this into an addition problem or a multiplication problem. I could say 6 crayfish times 3 inches is how long altogether? Say it with me. 18 inches long. Altogether, the crayfish are 18 inches long. All right, let's go to our next one. Oh, we just solved this one. Aren't we brilliant? All right, let's go to our next one. Mrs. Curie's students also measure the length of their crayfish. And this is from Mr. Nye's class still. We've seen this one before. They noticed the number of crayfish that are less than 3 inches long is half of the number of crayfish that are 3 inches long in Mr. Nye's class. How many crayfish are less than 3 inches long in Miss Curie's class? Well, we know that Mr. Nye had 6 crayfish that were 3 inches long, and half means divided by 2. So we can say 6 divided by 2 equals what? What times 2 equals 6? If you need to go ahead, do your skip counting, work it out. The answer, of course, is 3. Mrs. Curie's class had 3 crayfish that were less than 3 inches long. All right. Let's move on. Our next one says, Ginny uses half-inch square tiles to measure the longest crayfish. So how long is each side of a half-inch square tile? Well, if I show us a lovely square, I know that all the sides are the same length. So if one side is ½ I know all the sides are going to be ½ inch long. How many ½ square tiles does she use? Basically, she's measuring the longest crayfish. How long is the longest crayfish in her class? It's 3½ inches. So what I'm going to do is I'm going to put out some squares. Here we go. And we're going to count them up. So I've got 1 square. 2 squares, 3 squares, 4 squares. And let's count up using our ½ inches, seeing how long they are. So that's ½ inch plus ½ inch is 1 inch, 1½ inches, 2 inches. Not there yet. We need to get to 3½ inches long. So let's get some more squares ready. Actually, you know what? Let's just, what am I doing? Here we go. No. Undo. Oh dear. All right, let's make sure we've got another one. There we go. And then this one is 2½ Ooh, whoa. What is? Whoops, I'm sorry about this, everybody. Here we are. So this one here is 2½ inches long. And we need another square because we're not there yet. So we've got 3 inches long. And we're going to need another square. This thing. And let's move it into place. And we'll label that as our 3.5 inch long square. So let's count up how many squares we used to make a number line showing 1/2 inches to get to the length of the longest crayfish, which was 3.5 inches long. 1, 2, 3, 4, 5, 6, 7. 7 little squares to get to 3.5 inches long. So she needed 7 1/2 inch square tiles. All right, let's go to our next question. This question says, use the line plot and the chart below, that's this chart, to find the total number of crayfish that all the 3rd grade classes are studying. We know that this is Mr. Nye's class's chart up here. And we know Mr. Franklin had 21 crayfish, Mrs. Curie had 23, Mrs. Nobel had 24, but we need to find out how many crayfish are in Mr. Nye's class. How could we do that using our line plots? Well, we can count our X's. So let's go ahead and count them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So Mr. Nye had 21 crayfish in his classroom. Now we want to know how many all the classes are studying together. So I'm going to go ahead and find the total by adding them up. So I'm going to start off, I'm going to say 21 plus 23, because those were our first 2 numbers. 1 plus 3 is 4, 2 plus 2 is 4, is 44. And now I'm going to go 44 plus, and let's see what our next number on our chart was. Our next number was Mr. Nye with 21. So 44 plus 21. 4 plus 1 is 5. 4 plus 2 is 6. 65. And we've got one more teacher, Mrs. Nobel. 65 plus, and let's go back and see how many she was using. She had 24. So 65 plus 24. And now let's go ahead, we'll add them all up. 5 plus 4 is 9. 6 plus 2 is 8. 89. So all together, they were studying 89 different crayfish. So we did a great job there. All right, our next question. The crayfish are kept in small tanks. There are 3 crayfish in each tank. How many tanks does Mr. Nye's class need? Well, we know Mr. Nye has 21 crayfish and 3 of them can go into a tank. So we could say 21 divided by 3, or because what's easier than division? Multiplication. So we could say 3 times something equals 21. If you need to go ahead, do your 3 times skip counting down the side, whatever you need to do to solve our answer. I know that 3 times 7 is 21. So Mr. Cray needed 7 crayfish tanks to hold all his crayfish. All right. Now we're just going to have a bit of a chat about data and what we use different types of graphs for, because I know so far we've studied pictographs, bar graphs, line plots, tally charts. There are lots of ways to show data, but we need to think about when we should be using different kinds of graphs and what we would be using them all for. So I'm going to make myself a bit bigger here. There we go. And I'm going to be reading our screens to you. You should probably be following along as well. Data is shown in different forms depending on how it is used. Compare the money spent at the fair problem to Mr. Nye's class crayfish problem. would it make sense for the money spent at the fair to be switched to a line plot? Why or why not? Well, let's think about what each one is showing us. I know that the money spent at the fair, I'm sorry, it keeps doing that. It's in a very bad place. The money spent at the fair problem, and let's see if I can get myself back there. The money spent at the fair is talking about lots of money. At one stage, the most was $35. So if I had to do that on a line plot, I'd have to have 35 X's to show the money spent at the fair. That would be a really big line plot with a lot of X's. That wouldn't make much sense, would it? And I also know that the most in our line plot, the most number of X's is 6. So that if I put it into my bar graph, it would come to up like that. And all the other ones would be even smaller. So it's probably a good idea to use graphs that have bigger numbers, like multiples of 10 over here. And it's probably a good idea to use a line plot if it has small numbers, like all these 1, 2, 3, 4, 5, 6s. So smaller numbers you want to use your line plot for. Bigger numbers you want to use a bar graph for. Bar graphs are used to compare things between different groups. So for example, over here, we saw how much they spent for each thing, and we can compare them. Line plots show how often or how frequent the data happens along a number line. So this line plot showed us how often crayfish were a certain length, whereas this bar graph showed us how much money they spent. All right, if you wanted to show the number of coins in 4 piggy banks, which graph would you use and why? Would you use a bar graph or a line plot? Have a think about it. Well, I know I would probably want to use a bar graph because I'd show the different piggy banks as the items at the bottom, and then I could show the number of coins going up along the sides. But if I tried to do that on a bar graph, this doesn't show how many things I have in each group, does it? It would probably be good to show how many coins of each type I have in all 4 piggy banks, but it wouldn't help me compare how much each piggy bank has. All right, so we're gonna do a quick quiz and then you're gonna get started on your problem set. So for our very, very quick quiz here. Oh, can I do this without me? Come on, click, click, click. No? Uh-oh. Interesting. I thought I could do that. All right, well, oh, there we go. What we're going to do is we need to highlight what we would use each graph for. So bar graphs, we'd use that to show the number of fish in each tank or the number of students in each class. I'm going to highlight some words here that are really important to help us understand this. Or the amount of money saved each month. The number of magazines sold by each student. The number of visitors to a carnival each day. The number of coins in each piggy bank. I know that the word each is in each of these things that I would use to show on a bar graph because we compare each of the parts of it. All right, now I'm going to use my green or my pink highlighter to show what we would use line plots for. So I would use a line plot to show the lengths of the straws. I would use the line plot to show the time that they spend outside over the weekend. I would use the line plots to show the heights of children on the 3rd grade. Basketball team, I would show line plots to show the lengths of worms. I'd show it to show the lengths of plants' roots. I'd use a line plot to show the heights of bean plants. I'd use a line plot to show the heights of sunflower plants. And I'd use a line plot to show the widths of maple tree leaves. All these things, length, time, heights, and widths, can be measured. They're all measurements that you might be able to use a ruler to measure, or maybe you'd need a measuring tape, but they're all things that can be measured. Can we measure how many fish are in a tank? No, for that we would count. Can we measure how many students are in a class? No, for that we would count. Can we measure how many numbers of visitors come to a carnival every day? No, for that we would count. So if we're counting, we use a bar graph. If we're measuring, we use line plots. All right, grade 3s, you have been absolutely fantastic. It is time for you to turn to page 251 in your Learn books to do your problem sets. Page 251, 252, and 253. You have 3 pages to do today. When you're done, I know that your teachers will be meeting with you on Zoom and going over your answers and doing your exit ticket with you. All right, grade 3s, thank you for being absolute superstars. Get straight to work. We know we have a set schedule. We don't have time to lose, and I look forward to seeing you later. Bye, superstars. Thanks for your amazing hard work.